Hello and welcome. Dear guests, fingers crossed by the end of this session, you'll know your terrorist credit score. Isn't that something? This is what our next keynote speaker, Kate Crawford, tells us. Kate is not so much of an expert for terrorism, I think, but she's more of a brilliant scholar and writer in the field of data analysis, social media, and digital communication. Kate is originally from Australia and studied at the University of Sydney, where she co-founded the Communications and Media Department. She was the Deputy Director of the Journalism and Media Research Centre at the University of New South Wales in Sydney. Today, Kate is a visiting professor at MIT's Centre for Civic Media, a senior fellow at NYU's Information Law Institute, and at the principal researcher at the Microsoft Research New York. Microsoft Research New York was founded in 2012, and it's a touchpoint between academia and industry, designed to help developers understand how humans behave online and to predict their actions. Big data is what comes to your mind when you think about that area, and it is exactly where Kate's focus is. She's the co-director of the Council for Big Data, Ethics and Society, where she and her colleagues look for answers to the challenge that big data means for a democratic and free society. The intersection of ethics and big data is also what Kate will focus on in her keynote today. Kate is convinced that the old models of privacy are not keeping up with technology, and at the same time, she thinks we need a strong framework for data ethics. Please welcome on the stage, Kate Crawford.
Hello, everybody. It is such a pleasure to be here at Republica at last, and particularly a pleasure to be here on the 10th anniversary. And I have to say, it's also an honor to be speaking here after Richard's Senate, and I think you might find some interesting parallels in some of the things that we have to say. So, you might have noticed something strange happening with the current debates about the ethics of artificial intelligence. It's all about the singularity, that mythical moment when we might create an artificial intelligence so much smarter than us, so infinitely more capable, that it will actually overthrow the human race. Now, possibly there are some good reasons why this is the year where people are worried about it. Last month, we saw AlphaGo, which is a reinforcement learning algorithm, defeat one of the reigning human masters at Go in Korea. We also saw an open letter from a set of concerned scientists worried about the potential pitfalls of AI work. And of course, we just found out there's going to be a whole new trilogy of the Terminator series. So yes, any one of these might be enough to get people anxious, let alone all three in combination. But what is interesting here is that in many ways, the concern about the singularity is not new. It's been around since the 1950s with venerable mathematicians like John von Neumann, who initially expressed his concern at the very end of his career, and now most personified by Nick Bostrom, a philosopher who recently wrote the book Superintelligence. And the superintelligence thesis is that as our capacities to increase the intelligence of agents grow and grow, we might get to the point where we create a despotic AI that is able to self-replicate and can basically turn people into its slave labor. And what's interesting about this kind of perspective, of course, is that the singularity and superintelligence are still the stuff of theory. Even the people who believe that this is where we're headed say that it's decades, possibly centuries away. And some computer scientists say that it's basically not possible at all. But this hasn't stopped a series of very well-known people from expressing their fears. And of course, Elon Musk, the billionaire technology magnate, the CEO of both SpaceX and Tesla, went on a tweet storm recently expressing his concern about superintelligence. But let's take a look at the people who are the most vocal in their concerns about the superintelligence. Here are sort of the top 4. Can you tell me any similarities that you might see here? What can you see? Yes, absolutely. 10 points. They're all men and they're all white. And in addition to that, I would add, there's at least 2 billionaires up there and at least 1 multimillionaire. So I might just change my slides slightly to read this. The singularity might seem like a big problem if you're rich and white. But to be fair, I think we have to give them their dues here. There is a fear of creating an artificially intelligent apex predator, and that is particularly frightening if you are currently the apex predator. But for the rest of us, I would suggest that some of the threats that they're worried about are already starting to emerge. So what I want to suggest today is that the panics about the singularity are hiding the real problem. Amongst all of this hypothesizing about a terrifying future of non-biological intelligence running the world, we are failing to look at the technologies that we're already relying on in everyday life. The most pressing concern for me is not the superintelligent agents of the future. It's the inequality that we're embedding in the systems right now. So, if the thing that the singularity theorist fears most is effectively the disenfranchisement, the exploitation, and disempowerment of humans, this is already starting to happen. But interestingly, to coin a phrase, it's just being unevenly distributed. So what I think we should be doing is working to address these current forms of discrimination and inequality that are built into our big data systems right now. So, what do I mean by artificial intelligence here? I'm going to take us back to the original definition by John McCarthy. When he defined artificial intelligence, he described it as the science and engineering of making machines intelligent. But what I think is more interesting and almost a harder challenge is the social and ethical frames of how we make machines intelligent. And today I'm going to be talking about soft AI or narrow AI. What that means is AIs that are designed to basically complete a single task very well, but by no means are they self-aware, self-conscious, or creative. And unlike hard AI, soft AI is probably something you're already using. Some of the soft AIs have personalities and names like Siri, Cortana, Amazon's Alexa, Facebook's M. But many of them are faceless back-end systems. We could think of the image recognition systems that Google and Facebook use, for example. And their intelligence, such as it is premised on gathering as much data about you as possible. The Harvard academic Shoshana Zuboff uses the term surveillance capitalism to try and encapsulate both the ideological and the economic imperative to gather maximal data, both because it might support your profit model, but also because it helps train your data models so they can understand the world in a more and more fine-grained manner, regardless of whether or not that creates risks to individuals or to groups. So I'm going to give you a quick roadmap of the tour that I'm going to take you on today. First of all, I want to talk about the shift that I see happening from human subjects to data subjects and what that might mean. And then I'm going to talk a little bit about the limitations of both the 20th century models of privacy and transparency. And finally, I'm going to suggest why we urgently need a stronger framework for data ethics and why we need to do better on inclusion. So, there are many forms of autonomous software out there today. But as they become increasingly autonomous, we have to ask better questions about what kind of values they possess, what kind of worldview is being mapped onto their systems. And to begin, I'm going to take you here. This is a refugee camp, one of many that are currently housing the millions of people fleeing Syria in what has become one of the largest humanitarian crises of our time. But this is also the site of an enormous machine learning experiment. We recently found out that IBM was approached by a client who was looking at the refugees getting off the boats And they said, some of these people are looking too healthy. Is there a way that you could design a machine learning system that could separate the real refugees from potential jihadists? IBM said yes, they could. And using their i2 enterprise software, what they did is they ingested an enormous amount of unstructured data from places like the dark web, where they looked at where you might be able to buy a passport, for example. And then they looked at Twitter likes to see if people had been liking the same DJs or the same venues, and then cross-correlated that with parking tickets to see if they'd been possibly staking out those venues for extended periods, possibly for a bomb attack. And then they looked at various data sets that a border guard might have. And through this concoction, they created what they call a terrorist credit score. Now, IBM was quick to point out that the credit score is not a definitive marker of guilt or innocence. But nonetheless, this is an extraordinarily intimate profile of what someone is like, where they work, what their social graph looks like. All of these forms of trace data that are extremely personal to us, but that are effectively still defined as public data. So what concerns me about these kinds of systems is that we're ultimately doing two things. On one side, we're creating all of this room for spurious correlations, for errors, for false positives, for the sort of difficulty of how you would even verify these predictive suspicions kind of boggles the mind. Certainly in my research, I look at the way the bias creeps into models and the way that both at the algorithmic level and at the training data level, we can start to see these errors emerge. But what concerns me most is that we're creating these unverified systems for predicting forms of crime, ultimately under a proprietary secret. We have no idea how that system is really working, and there is no ability for an accused person or a refugee to possibly see that data or to question it. So I think for me, this also highlights something I want to talk about today. Privacy is being stretched to its limit to try and contend with these new forms of dealing with data. Let me quote from IBM. This is a quote that came out of Defense One, which is a military publication where this experiment that IBM was running first became public. IBM representatives pointed out that the i2 doesn't collect intelligence, it just helps ingest and make sense of unstructured data. So they aren't spies or agents or operatives, they're just engineers. Feel better? Maybe not. But this is a very carefully constructed argument, and let me tell you why. When they say they're not collecting intelligence, what they mean to say is that they're not directly coming up to you and getting your PII, your personally identifiable information. Instead, they're just getting all of this public unstructured data, which is much harder to have any kind of privacy complaint about. But also, I think what's interesting about this is that systems like the i2 are already inferring an enormous amount of sensitive data about people. This is already happening. And to some degree, they're outside of the bounds of what privacy law was designed to protect, even though they are in many ways so much more invasive, so much more able to tell us very, very personal things. Now, the theorist Jasmine Puar has this fantastic concept of the trace body that she uses in her book, Terrorist Assemblages. A trace body follows our physical body, and every time we cross a border, for example, both our trace body and our physical body are under extraordinarily high levels of intense surveillance. So what's interesting about public data is that even though it can seem relatively trouble-free, I mean, what's wrong with public data? When it becomes connected to your trace body, it can prevent you from crossing borders, from catching a plane, from getting healthcare, and from getting a job. So what happens to these trace data bodies is actually extremely important, as Jasbir Puar has pointed out. And for me, the reason why I think the refugee example is so powerful is because it highlights how public data is feeding these machine learning experiments that are intensifying surveillance ultimately on the least privileged, on the people who are least able to fight back and to question the use of these systems. how would you ever contest your terrorist credit score? I mean, this is the irony of the title today, because how would you possibly even know that somebody had generated this score about you, let alone question the kind of data they were using? Now, Donna Haraway has this fantastic phrase where she talks about the common move of the technological sciences, where they try to reduce the world to a problem of coding. She describes this as an informatics of domination. And I like to think of the history of this kind of informatics of domination. We can go back here because obviously I can't really be standing in Berlin without thinking about the resonance of IBM's earlier systems of informatics. This was actually produced by IBM's subsidiary in 1933. This is the Holoranth punch card system. In many ways, it's basically the predecessor to the computerized database. But this was being used extensively by the Third Reich to track and identify Jews, Roma people, and other ethnic minorities. And these punch cards would record gender, nationality, profession, as well as ancestral line, family trees, known associates, for example. This was a very core part of how populations were being tracked and managed. And in what is possibly the most terrifying promotional poster of all time, this is the advertisement for the Holoranth punch card, which says, and I translate, "See everything with Holoranth punch cards." So you have a gigantic eye, which is like seeing like a state in its most literal formation, beaming light onto the ground below through the perforations of the punch card. So these systems have histories, and in many ways they illuminate the paths that we take towards massive population tracking and classification. So, to return you to the present day, my hope is that we can start to broaden these very narrow debates about the ethics of AI to start talking about real-world ethics now and how we got here. We're living in this era of massive data collection, of deployment of sensors throughout cities, which indeed Richard Sennett talked about earlier today, as well as predictive analytics. And what I'd like to suggest is that it's making us into data subjects, little points within enormous aggregates, which are effectively being assessed compared to probabilistic models of human behavior. And I think to understand the shift from human subjects to data subjects is going to be really important if we're to try and understand how to build systems in order to make them fairer. But what is interesting, of course, is that data subjects have a very different experience depending on who you are. So what I want to do is talk a little bit about the ways in which some data subjects experience discrimination and misrecognition at the hands of some of these systems. So, machine learning systems, as, if you will, the precursors of the AI to come, have been experiencing this extraordinary rapid advancement in the last 5 years. And actually, that's part of the reason there's been this huge excitement about AI again. But interestingly, we can learn a lot by looking at where machine learning is failing, where it's basically not working. Now, you've probably heard about Google's Photo app, which basically is an image recognition algorithm. So you import all of your photos, and it will basically tell you, oh, that's a bunch of people at Republica, or, oh, this is a vase of flowers. Or if you input images of your black friends, oh, here's a group of gorillas. So a user found this particular error, and you can imagine they were not very happy to see that their white friends were not being miscategorized, but their black friends were. Now, Google apologized profusely for this, as you can imagine, but it's clearly unintentional. What this teaches us is so much about the training data that this system was built on. We can presume that, in actual fact, this system had just been trained on so many white faces that when it saw non-white faces, it was basically calling them gorillas. This is so interesting to me because it's exactly this moment at which training data reveals how you're coding the human norm, how you're understanding what the average human looks like. And this tells you that black faces are not part of it, and that's a problem. But this isn't new. Let me show you another one. This is Nikon's camera software that initially was detecting all Asian people as permanently blinking. Bit of a problem. Another one was Hewlett-Packard, where for its image recognition, it was basically unable to detect anyone who had dark skin tones. And HP's response was, maybe you should just use better background lighting. It'll be fine. Don't worry about it. But again, this is showing us the working logic behind how these systems are being trained. Beyond the world of visual recognition, there are concerns about discrimination in law enforcement and in employment, and I'll just talk briefly about these. Now, some of you in the room will have heard of New York's Stop and Frisk program. It's not something we're particularly proud of, but during its operation, 4.4 million people were stopped and frisked in the streets of New York. Guess how many of them were Black and Hispanic? 83%. Pretty shocking. And just in court, when it was found that this system was indeed illegal, the judge said that this was basically an inadvertent form of indirect racial profiling. Now, just imagine for a minute if you gave that data to an AI system. If it would say, well, if 83% of the people being arrested are Black and Hispanic, well, clearly, they're the people who are the most suspicious and probably the people who are committing most of the crimes. That is certainly one interpretation of that data. But another interpretation is that those extreme numbers represent a deep and divisive history between the police and communities of color in the US, and indicates that we need much stronger civil rights protections. Two different stories, same data set. And this isn't just a matter of hypothetical speculation. Right now in the US, lots and lots of police departments are rolling out predictive policing. I'm talking about New York, Chicago, Miami, LA, just to name a few. Now, to be clear, predictive policing is not an AI system by any stretch, but it's a lot closer to us than the superintelligence. And that's why I think we should be paying much closer attention to how it works. So basically, predictive policing imports an enormous amount of historical data about where crimes have been taking place, and then will generate this type of heat map, which will tell police where to spend their resources, where they should go to look for suspicious activity. But you could see how you can create a particular type of reinforcement error here. If historically the poorer Black neighborhoods have been seeing more police surveillance and more arrests, they're going to come up as being an area of concern. So the police will continue to go there, surveil more, arrest more people, while whiter, wealthier neighborhoods will be actually getting far less scrutiny. So what is interesting about these kinds of approaches is that unless we think about the long history of race and class and policing when we design systems, we run the risk of creating these supposedly objective, data-driven models that nonetheless carry these deep biases right in the infrastructure of how they work. Now, here's a new one that you might have just heard about. It broke last week. Bloomberg did a big investigation of various zip codes in the US and where Amazon Prime was offering same-day delivery to its Prime customers. And surprise, surprise, what they found was that predominantly Black neighborhoods were not getting access to same-day services. And that matters because for some people, that's where you're ordering your fresh fruit and vegetables. If you live somewhere in the US, it's a food desert and you're nowhere near a supermarket, same-day delivery can really change the way you eat, the kind of things you have access to. So take a look at let's have a look at Boston, where I used to live back in the day. Roxbury is by far and away one of the most Black neighborhoods in the center of Boston. And look, right in the middle, it's the only area that doesn't have service. So what is really interesting about looking at this kind of data is that these maps are almost exactly the same as the early redlining maps of the US. And interestingly, redlining came about because of the National Housing Act of 1934, which unfortunately ended up resulting in fewer Black families being able to get mortgages. And the Federal Housing Association used to have these maps of cities, and they would draw circles in red around the areas where you couldn't get mortgages, looking very, very similar to the kind of maps that you see before you here. So again, we see the way that discrimination starts to live on in these digital systems deep in the infrastructure of how they work. So we've talked a bit about race. Let's talk about gender. This picture here is the thing that you will get if you type into your preferred search engine, CEO. Yes, you'll notice a few other similarities here as well. And what's interesting is that if an AI was scanning the top results from its top searches and said, oh, well, this is just what a CEO looks like. It's a guy in a tie. That's what a CEO is going to be for me. And this isn't, again, something that is just a joke, because if you look at a study that just came out from CMU, we're starting to see these very problematic ways that certain kinds of opportunities are being made invisible to women. So what the researchers did is that it created this enormous automated system called AdFisher. All of them were fake accounts. Half of them were labeled as men, half of them were labeled as women. And then they went and saw what kind of job ads they were getting served by Google. And what was interesting is that a far, far greater number of the male accounts were getting ads for highly paid jobs, jobs in the kind of $200,000 a year category, and for career coaching to try and get them those jobs. Women just weren't seeing them at the same rate. This is a problem because this type of reinforcement means that women are not going to see these opportunities, they're not going to apply for them, and they're certainly not going to get those jobs, which then reinforces this pattern that men are the target market. You should pitch your ads to men because they're the ones who'll apply, they're the ones who'll get it. So you can see how we create this kind of vicious circle. Now, the researchers were very careful to point out that we don't know if it was because basically advertisers were targeting men or if it was an unintended side effect of the machine learning algorithms. But that difference matters. That's an incredibly significant thing to know, and we have to know that if we're ever going to ensure that we have equality of opportunity in these kinds of systems. Otherwise, we risk importing that bias into the AI systems to come. So this is why I want to connect the debates about data discrimination to artificial intelligence. If we look at how systems can unintentionally discriminate now, we're much better placed to design fair AI. Now, one of the best recent examples was Microsoft's Tay. You might have heard about this. In the 24 hours that she was active, she went from being a charming and friendly chatbot to being a belligerent, anti-Semitic misogynist. It was quite an achievement. But what was really interesting, and I think the great lesson of Tay, is that when systems are designed to reflect the values of their users, they can be manipulated. And essentially, the future of AI depends on addressing those kinds of social and ethical questions as much as the technical ones. So, I've basically given you multiple examples of where bias can creep in, through overly narrow training data, through the interpretation and perpetuation of historical data, through to these kinds of effectively restrictive targeting. But Tay reminds me that the bias doesn't have to come from the data, even if you had a perfect system. When people start using things, they can bring their own prejudices and biases to the table. So we have multiple systems working at once, which is why these spaces are so complex and so fascinating. Ooh, so what are we going to do about it? Well, certainly in terms of the massive data collection that's been going on, a lot of people have been turning to privacy as the framework that can help us answer that. But I'd like to suggest that privacy has a threat modeling problem, which is that it is currently modeling in ways that are missing half of the things that are happening in the machine learning universe. So basically, privacy has always mapped to the dominant media forms of the time. In the 1880s, it was all about newspapers. You could possibly write salacious stories about your love life. And then when it was the emergence of photography, the concern was, how do we stop people from taking photographs inside your windows? But then we see the emergence of these guys, early computing. And at this point, basically, the way computers got information about you is that you would log in, give information, log back out again. So we start to see the emergence of the fair information practice principles, which are these undergirding positions around what data privacy means. It's things like notice and consent. I give you notice about how a system is going to work. You either give me consent or you don't use it. Another classic principle from this era is the idea of access to your data, that your data is sitting there, discrete, you can go and have a look at it, and you can access it whenever you want. And then finally, the idea of reinforcement, that if I do something with your data that you don't like, you can have an action against me. Fair enough. But then we start to move into the 1990s, and something interesting starts to happen. I tried to find the most 90s image for you, and what I found was this. This is two of the cast of Friends, Jennifer Aniston and Matthew Perry, doing an infomercial about how to use PCs. Absolutely priceless. I think it's basically quintessential 90s right here. So obviously this is the time where we see the mass popularization of the internet, but also the rise of online advertising, targeting in ever more invasive ways everything that you're doing online. So here, the threat model changes from one-to-one to many, because we now know that data brokers are buying and trading data sets and combining things. And here we start to see this metaphor of privacy, which is built around a three-part process: collection, use, and disclosure. Well, what I'd like to suggest is that basically that three-part process has broken down, and that it's really difficult to think about what collection is in a predictive system, what use is when you're doing a whole set of different kinds of inferences. In this metadata and machine learning era, we're starting to see this enormous trade in behavioral data. That's data that you're probably not even aware that you're shedding every day. Every time you read an article online, every time you buy something, every time you walk past a facial recognition camera, it's collecting emotional data about your face. Every time you wear a wearable fitness band with a galvanic skin sensor, it's getting enormously intimate data about how you feel from minute to minute. And now we can add long-range iris scanning and facial recognition at a distance. This particular slide came from a presentation from a CMU researcher. And as you can see, the girl is saying, "It looks like Susie has a new boyfriend. I wonder who it is." And the system says, "That is Bill Baker." Nothing creepy about that. Nothing at all. It's kind of extraordinary, actually, that they were using this to promote the system without thinking that maybe people might find it a bit odd, a bit disturbing. Yes, perhaps all you have to do is imagine that system being used in a public protest and recording the names and faces of everybody walking past, and maybe that will start to seem creepy too. And of course, cities are already starting to use these kinds of systems. Back when I was living in Boston in 2013, something very unusual happened. There was a big outdoor music festival. That's not the unusual part. Lots of visual bands were playing. It was like the National and the Dirty Projectors, and thousands of people wanted to go. It was in the big main part of the city outdoors. But what nobody knew who went to that concert, and the promoters didn't know, is that every single person who walked in was having their face recorded and then run against an algorithm to determine their race, their age, and their gender. And when this finally came to light, the city of Boston said, "Oh, look, we're just doing it as an experiment. It's about ensuring security in public events. It's going to be fine, guys. Don't worry about it." Which, if you think about it, is just another dog whistle for terrorism. And this makes sense, because this particular experiment in Boston happened 2 months after the Boston bombings. So we're used to seeing this kind of operationalization of the rhetorics of terrorism as a way to increase the already flourishing infrastructures of surveillance. And why this is really going to start to matter is that this is already happening. That's 2013. So know that most people in this room probably already have a terrorist credit score, but there's almost no way that you can find out what that is. So ultimately, we're at a position now where systems don't even need to gather data about you directly at all. They can infer it from your social graph, from a whole lot of different trace data points. I've written about this in a couple of research papers and described it as predictive privacy harms that basically live outside of the previous metaphors that we had for privacy law. And we just don't have new metaphors to deal with these kinds of systems yet. For example, how do you protect something from somebody who is inferring it about you? What if a system basically predicts something about you that you don't even know yet? How do you have any kind of rights over that information? It's a really hard question. So what we're starting to see is a lot of activists and academics move into the question of transparency, that somehow transparency will give us accountability if privacy can't. Well, if the theory here is that you just unlock the black boxes and that you can then somehow understand how they work and produce accountability and governance, I'm afraid to say I think it's going to be a lot harder than that. And here I'm drawing on research that I'm doing right now with Mike Anany at USC. And what's interesting here is that, of course, computer scientists have had a long interest in how to visualize and represent and make transparent their systems. This is a beautiful system, which if you look at online on sorting out sorting, you will see all of these different sorting algorithms represented and animated. It's a fantastic way of looking into how something works. But how do we do this with, say, the types of machine learning algorithms that I've been talking about today? It's a lot harder. What are the metaphors for how I actually show you how they work? So this is one I particularly love. Or see all of the little Acer screens are learning from the one in the beginning. That's machine learning right there. So we're starting to see academics like the excellent Frank Pasquale demand greater transparency of algorithmic systems. The idea here is that transparency, if you could have this visibility, if you could look into it, you would understand it, and then you would be able to make it accountable. But I think we can question almost every jump in that logical tree, because there are very real technical limitations to how transparency could work. Ultimately, it's really difficult to open a black box on these kinds of systems. This is because even to the creators of some of these systems, they can't tell you how they work. So if you have a chat, if you get the chance to talk to some people here who are working on deep neural nets, they can show you that these systems are really good at detecting the faces of dogs or the faces of cats, but they won't necessarily be able to tell you why it's so effective or what the logic is that allows that system to work. And they have all of the data and all of the underlying programming, and yet even then, transparency isn't enough. And there's this other fantastic paper that came out in 2015 that showed you how easy it is to fool a deep neural net. These are just a set of abstract pictures and images that they fed into this system, which was saying with certainty that this squiggle is a bagel. And this little representation up here is clearly a comic book. And down here, yeah, that's a monarch butterfly. And what was interesting again is that why these systems fail versus when they succeed is still somewhat mystifying. This is my favorite one, where they basically input a picture of the Queen of England, and it says with 99.7% certainty that she is a shower cap. Fair enough. I'm not sure how the Queen's going to feel about that prop. Not very good, I'm guessing. But here we go into a different world of vision. And something that is particularly fascinating here is that even though we might be offended by some of these misrecognitions, it's not coming from a universe where these misrecognitions have any value. It's a machinic way of seeing. And this is something that artists like Adam Harvey and Trevor Paglen are researching at the moment. But basically what this means is that transparency is part of making a system accountable, but it is by no means sufficient. All right, so the other thing that I love is thinking about temporality and transparency. This is a representation of high-frequency trading, just a few seconds of it. And what is interesting about it is if you think about if you wanted to have a look inside the black box, if you could even just see a few seconds of this, it's changing so rapidly. What part represents the true system? Let me give you another example. This is a visual representation of high-frequency trading done by the design firm Stamen working with NASDAQ. This is exactly 1 minute of trading on March 8, 2011. And let's say I actually understood how a system was working right here in the middle of that, right in the middle of that minute. Very different to what's happening over here or what's happening over there. So this gets particularly tricky with adaptive systems that are learning all the time as they get more and more data. Even if you think you've got all the training data, you've got the algorithm, and you've got the testing data, you're still only getting a snapshot, 1 moment. Whereas in actual fact, this is a system in flux. It's changing, it's learning. You're really not getting a sense of how it's affecting people, let alone how it's affecting different users. So I think when we have any idea of transparency or auditing, we have to contend with this temporal dimension, or we're really missing this idea of accountability at all. So looking inside the black box, I would suggest, is a bit of a red herring, because ultimately it's a redirection from the material and ideological consequences of the systems that we're building. Besides, there's not just one black box. There are many black boxes, and they're all actually interacting with each other and producing unexpected effects that differ from user to user. So Marvin Minsky, who was one of the founders of AI, said, if you only understand something from one way, then you barely understand it at all. And for me, I think about that in relation to these systems, that we have to look at these broader forms of understanding within social contexts and trying to think about accountability. Which brings me to the turn to data ethics. So I like to remind myself sometimes that the trajectories of technological development are not inevitable. You can actually intervene in technologies as they're growing. You can actually limit their dangers. And we've seen this with technologies like nuclear power. And this is interesting too, because I've been going back and looking at the history of how ethics codes have been emerging with the fantastic postdoc, Jake Metcalf. And what's fascinating is that concern about ethics spikes when you have periods of enormous technological or scientific change. But you know what it takes to make an ethics code? A crisis. You need something really bad to happen, and then suddenly everybody is all about ethics. So historically, we can look back at the medical atrocities of World War II, which then brought about the Nuremberg Code in 1949. We can look at the type of ethics crises that happened in the 50s and 60s, which then resulted in the Belmont Report of 1979, which lives on today in what we call the Common Rule, which basically mandates how academics can do ethical research. And again, we could look at what happened with the rise of bioethics. That came about because of the rise of genetics, organ transplantation, and all of the technologies that we use to extend human life. And what is interesting to me is that bioethics shows us that we need really clearly delimited fields to deal with specific technologies. And they come at these critical moments. And what I'd like to suggest is that we're having a critical moment right now, and that we urgently need to have a rigorous sense of data ethics underpinning the systems that we're building today. All of these ML and AI systems that I'm talking about raise whole new questions that the old frameworks of privacy and transparency are really struggling to keep up with. The other reason why I think we have to start talking about ethics now is because it's already being pulled in multiple directions. You have the singularity guys who are basically talking about ethics in terms of the rise of the robots. On the other side, you have ethics in terms of corporate compliance as another set of checklists that we just tick off. But I'd like to suggest that there's a third way of thinking about ethics, that we deal with real-world implications of the technologies that we're building now, and we look at the kinds of power asymmetries that are being perpetuated and in some cases exacerbated by them. That, to me, is how we really start to make ethics matter in these kinds of systems. And it doesn't mean we have to give up on privacy at all. It just means we need to put it within this broader framework of ethics, because in so many cases, these systems are doing things that live outside of the privacy laws that we have. So, if we're going to understand this new realpolitik of data subjects, it seems to me that we have three big areas that we need more work on, and I'm hoping that some of the people in the room today are working on these kinds of questions already. One is fairness. How do we decide what fairness looks like in a system? How do we start to compare the way one user is being treated compared to another? And the other, of course, is power. What do we do with these new power asymmetries, and how are they affecting our definitions of citizenship, participation, and democracy? And then finally, due process. How are you going to intervene in a system? If you're designing something, think about the way in which people can actually find out the data that you're using about them. They can actually correct the record if you're using incorrect data. And this matters because you're getting scored for everything right now. You're getting an employability score, you're getting a health score, and you're certainly getting a terrorist credit score. So due process gives us a way to intervene into that kind of metric making of human life. I want to give you a ray of hope before I finish, that change is possible. You might remember the Facebook emotional contagion experiment of a couple of years ago. Basically, Facebook was experimenting on 700,000 users without their knowledge, and they were either seeing the happy newsfeed or the sad newsfeed. And what they were doing is checking to see if they could manipulate your emotions so that you would start to post either happy things or sad things. Now, in the international furor when this went public, something really interesting happened. Facebook introduced an ethics system, an actual protocol that researchers have to go through if they're going to start conducting these kinds of experiments. Now, obviously, that is a private ethics system. We don't know how it works, but it's a lot better than what they had before, which was absolutely nothing. So what's interesting here is that public input actually saying what you think about these systems, it matters and it can produce change. And I think that is something that actually gives me a lot of hope. So I want to end today by going back to the beginning of my talk and asking you this. Who gets to design the AI future? Whose model of the world are we taking as ground truth? So this is one possibility. This is Mark Zuckerberg at the launch of the Oculus. Pretty homogenous looking audience there. And what is interesting is that artificial intelligence will, for the foreseeable future anyway, reflect the values of its creators. So it really matters who is running these companies, who is designing these systems, who is sitting on their ethics boards, because these are the people who will get to decide what kinds of systems we're going to be living within. And when it comes down to it, artificial intelligence systems can basically mirror a very narrow and privileged model of society if we choose to let them. But actually, I think it's critically important that for the ethics of AI, we want to start demanding greater diversity and inclusion now. We want to make sure that these systems are considering the communities that have the least power, the ones that have the least visibility. Because in this sense, as people start to build these worlds, we want to make sure that these are places we want to inhabit. Thank you very much.
Kate, you certainly have a captive audience, and it was really fascinating listening to you. My question is, what was your motivation to get into that exact intersection of big data and ethics?
Okay, to be super honest with you, I first got interested in this space by starting to do large-scale data studies. I started out, almost 7 years ago now, looking at Twitter data, and in particular, Twitter data after a crisis event. And the theory was that we could look at Twitter data and it could tell us things like, what was the most affected community? Where should you send resources? But what I was noticing is that Twitter data is extremely skewed. I mean, basically reflects young, privileged, urban populations. So if you're starting to use that as how you understand what's happening in a disaster, you're basically sending resources to the privileged, and you're giving the people who are likely in the best possible position the most help. And so that's when I started looking at these issues around inequality and how we design fairer systems.
It's really interesting.
Yeah.
Are there any questions from the audience? I see a man with a beard and a blue dress over there. There are hand microphones coming.
There's
right
one
there?
coming up to you.
There? With a beard?
Right there.
Yes. Thank you, sir. Would be nice if you could introduce yourself really quickly.
Hi. Is it on? My name is Alexei Valikov. The following question. You were talking about data ethics. What my experience is that ethics in general do not reflect positively on the profit. Quite the opposite. The less ethics you have, the more is your profit. And we are also talking, as you were describing the AI, we were not talking about governments in the first place. We were talking about Facebook and Google and everything else. Mm-hmm. So we were talking about private companies. Mm-hmm. So my question is, what would be the incentives for private companies to introduce ethics to reduce their profits? How is that going to work? It's a nice thing, but how is that going to work?
I love it. You've gone straight to the hardest question. This is fantastic. Thank you for that. All right, there's two ways of looking at this. One way is that ultimately they don't have a choice. If we're going to start using these systems and relying on them, you do have the force of public pressure to start to say, we're going to demand due process. We're going to demand forms of accountability. That's possibly a little bit Pollyanna-ish and maybe to some degree too hopeful. But the other side is to say that it doesn't necessarily have to eat into your profit models at all. A lot of the things that I've been talking about are things that you could actually generate into your systems without necessarily increasing the cost. I mean, there are some really interesting studies right now that question this idea that gathering as much data as possible actually makes your company more valuable. And I think what we're going to see over the next 5 to 10 years is a much more nuanced account of what makes a company actually worthwhile. It's not just that it has an enormous amount of data, it's what it's doing with that data and how it's actually treating the people who are represented there. So I guess in my more optimistic moments, I'd like to say that data ethics has to happen, and ideally, it's the sort of thing that will actually not damage your profits, but in theory will actually make you a company that people are more likely to trust and more likely to use. But I'm absolutely agreeing with you that this is going to have to be part of a much larger landscape of how we think about the use of data, and it's going to be a hard set of problems.
We have time for one more question, please. Is there anything right in front here?
Right here.
Fantastic. Can you please get the microphone to the lady in the first row? Thank you.
Hi, and thank you for the fantastic talk. My name is Agnieszka Krzemińska. I'm just asking myself if it's not difficult to how to convince the users themselves, because I think one big obstacle in this data ethics question are the users themselves. They are more looking after a comfortable way to get things, to use gadgets or tools or apps, and are not as much concerned with these questions like you thought. What do you think? Is it, do this have to lie in the hands of the companies themselves, or how to convince the users after all?
So I think this is getting to this core perception of what do users value? And there's been this sort of very dominant belief that people don't care about privacy, they don't care about what you do with their data. And what's interesting about this is that who really knows how your data is being dealt with? To some degree, this is an enormous literacy problem, that we assume that people know and they don't care. The other problem is that we assume that people have a choice. In many cases, we're dealing with a system where there isn't an alternative for you to go to. So you're basically putting up with the fact that you don't have a lot of autonomy and control over your data. But what I'm really sort of inspired by are the people who are doing studies looking at how communities are engaging with these systems to try and change the way they work. And I'm thinking here of a book by Helen Nissenbaum and Finn Brunton called Obfuscation, the way people try to actually hide within systems, where they give fake data, where they use systems like Signal and Tor. We're starting to see this kind of resistance to systems that will over-collect your data. Now, do I think that's a long-term strategy? No, I don't. I actually think that's an arms race that we can't win. I think it's much, much more powerful to start thinking about how we train the data scientists and the computer scientists of tomorrow to start thinking about these kinds of ethical frameworks. I honestly think this starts at university and possibly even earlier, where we think about the fact that data isn't just this sort of random thing that is just out there. It's representing actual humans. It's people's lives. It has this radioactivity that can impact on somebody's employability or their ability to get health insurance or their ability to sort of get on a flight. When you start to look at data that way, I think you use it with a lot more care. So for me, I sort of think about my great hope is that we start to introduce these kinds of ethical frameworks into how we teach computer science, into how we teach data science. And that, to me, I think is going to produce an enormous amount of change.
Kate, we could listen to you for hours, obviously. Everybody's really fascinated, and it is a fascinating topic. Please bring your questions, if you still have them, to a gathering on Wednesday. It's at the Digital Eatery here in Berlin, and it will be hosted by Microsoft, and Kate will be there too, I believe. Yes?
Absolutely.
So thank you for coming today, and thank you, Kate, very much. It was really a pleasure.
Thank you. Thank you all.